Hello. Hello, these are notes for Algebra 2, Chapter 5, which is our chapter with radicals in it. These notes go with multiplying and simplifying radicals. We'll be getting a lot of practice on radicals throughout the chapter, but I wanted to go over the basic rules with you that hopefully you're already somewhat familiar to. Okay, Roman numeral 1, we're going to start with some vocabulary. Remember, too, that with a recording, you can always pause the recording if you fall behind to fill in the notes. All right, over here, we're going to put kind of a big 3, radical 7. Okay, so the first vocabulary word you need to know is the radical sign. The radical sign is the actual radical shape right there. As far as order of operations go, the radical sign is a form of grouping symbol, which means that you have to simplify everything inside the radical before going outside of the radical. Second word, radicand. The radicand, sometimes called the principal, is the inside number. In this case, that would be the 7. That's the radicand of the radical. Third term, the root of the radical, or the index, is the small number that you see right in this area. If you don't see anything in that area, it's automatically what we call an implied 2, which means there's an invisible 2 right there. Basically, the root or the index tells you the number of factors needed to simplify. So if it's a root 2, you have to have 2 of the same factor, 1 comes out. If it's a root 3, you have to have 3 of the same factor, 1 comes out. Now, we usually use root 2 and root 3, so they have special names. The square root is the implied root, or the invisible 2. That's a square root. The cube root refers to when there is a 3 in that position. So 3 terms, 1 comes out. So those are the basic vocabulary words that you need to know to work with radicals. I will typically be using radicand instead of principal. I use both root and index depending on what we're doing. Roman numeral 2, finding roots, which is another way to say simplifying. All right, and we're going to start with just numbers, simplifying out numbers. So, for example, square root of 50. So the first thing that you do when you simplify is you're going to prime factor the inside number. And we practiced that before the break, so you should be really good at prime factoring. Well, 50 is 5 times 10. 5 is prime. 10 is 5 times 2. So prime factor the radicand. The simplifying rules say that for every 2 of the same factor, 1 comes out. So 2 5s, 1 comes out to the front, and it gets multiplied by anything that's out there. Since there was only a 1, an invisible 1, it's just going to be a 5 and then square root 2. So once you've pulled out what you need to take out, you need to multiply the scalars and the radicand back together again, so you have one number inside, one number outside. Okay, let's do another example. Let's say that you have a negative square root of 32. Now, as we've talked about in class, you can't have a negative without a 1 attached to it. So it's just like having a negative 1 being multiplied by the radical. So we prime factor the 32. 32 is 8 times 4. So 8 is 222. 4 is 2 times 2. So there's a lot of things that are going to be coming out. 2 2s, 1 comes out to the front. 2 more 2s, another one comes out to the front. And we have 1 2 left over. So multiplying the scalars, 2 times 2 times negative 1 is a negative 4. And then all we have left on the inside is a 2. So your answer is negative 4 radical 2. Now at some point, you're going to be told to leave your answers irrational. In terms of radicals, any type of number that is left in the radical after you've simplified automatically means it is irrational, because that number is going to be a non-repeating, means it doesn't repeat over and over like 0.33333. It just has lots of random numbers. It's also non-terminating. So a non-repeating, non-terminating decimal is why radical 2 is irrational. And you can check that on your calculator. Radical 2 ends up being something like 1.4121, and then it just keeps going. So this would be an irrational answer if that's what they're looking for. All right, so let's do another example. This time we're going to do a cube root so that you're familiar with it. We're going to do example 3. We're going to do 2 times the cube root of 24. So the beginning of the problem is the same. You're going to prime factor the radicand. 24 is 6 times 4. So 2 times 3 for the 6, 2 times 2 for the 4. Now the difference is when it is an index of 3, or it's a cube root, every 3 factors, 1 comes out. So I have 1, 2, 3 2s, 1 comes out to the front. And that other 3 is stuck inside. So 2 times 2 is 4 for the scalar. Be sure and put the small 3 in there to show it's a cube root. And you have a 3 left over. So 4 cube root 3. All right, we're going to do one more of these, and then we're going to go on to variables, which are a little more complex. You're going to be asked to do some simplifying with decimals. For example, the square root of 0.0036. To simplify a decimal out of a radical, here's a trick that usually works. Count the number of places. 1, 2, 3, 4. This decimal has 4 places. And we know that we need 2 identical numbers for 1 to come out. So you take the number of places and you divide it by 2. That gives us 2 places. So when you are factoring this, you know that 36 is 6 times 6. So you're going to put your 6's in their own parentheses, and then you want 2 places, 2 decimal places for each of them. So you're going to do a 0.06 for the first one, 2 places, and 0.06 for the second one, 2 places. Now we have 2 identical decimals, 2 0.06's, 1 comes out. There's nothing left inside the radical, so the radical disappears entirely. Your answer is 0.06. Moving on, part 2, we're going to simplify variables. And variables are broken into 2 categories. The first one is with what we call an even index. An even index, which means, of course, you're going to have a root 2, root 4, root 6, root 8, all even numbers. So the dilemma with an even index is you're trying to work backwards to an answer that has disappeared. For example, if x squared is equal to 4, well, we know that 2 times 2 is 4. The problem is positive 2 times positive 2 is 4, but negative 2 times negative 2 is also 4. So, of course, the question becomes, which one is it? Well, the answer is we don't know, so we're going to have to show both. We have to show that there are two ways this could possibly go. So we did a little bit of this when we were solving with radicals. If you remember, we got the square by itself. We took a square root of both sides. Two x's, one came out. It was positive and negative. 4 is 2 times 2. It's a perfect square. So 1, 2 comes out. And then we simplify. Positive x is 2. Negative x is 2. So we get x equals 2 and x equals negative 2. Two answers. If you're solving something like this and you have to get two different answers, your answer format can go one of two ways. You can have x equals plus and minus 2 with the plus minus symbol, or you can have the absolute value of x equals 2. Absolute value of x equals 2 and plus minus 2 are actually the same thing. Typically, we do the plus minus when there's only one letter hanging out, and we save the absolute values for multiple letters. But we'll do that in a second. All right, let's do a simplifying example. We are going to simplify the square root of 2x squared. The first part of this is the same as before. You're going to prime factor. So 2 is already a prime factor, and then I have an x and an x. So 2 x's, 1 comes out to the front, but because it was x squared, we don't know if it was a positive x being squared or a negative x being squared. So we put bars, absolute value bars around it to show both types. So your answer is absolute value of x radical 2, or you can say plus and minus x radical 2. Both are acceptable answers. Okay, let's do another example, a little more complex. In this example, you have a negative scalar, a square root, and this time you have a binomial being squared, not just a single number. So if you have a binomial being squared, when you prime factor it, you have two of them, x plus 5 times x plus 5. So 2x plus 5s, one of them comes out, and it is being multiplied by the negative. So we have x plus 5 coming out. This would be a good time for absolute value bars. Multiplied by the negative, and there's no more radical. Sometimes the worksheets will let you stop there. Other times they're going to want two specific answers. If you can do 1 for 2, this one will work. If you have to give two specific answers, then you will need to split this into a negative times a positive x plus 5 and a negative times a negative x plus 5. So basically you have a positive and a negative binomial. And then you just simplify. On this one you would distribute the negative and get negative x minus 5. Here a negative times a negative is actually a positive. So the x plus 5 is unaffected. And those would be your two answers. So be looking at the key or the directions, and they will give you a hint as to which way you're supposed to answer, but be familiar with both. All right, example 3. The square root of 2x squared plus 20x plus 50. Now, because of all the pluses in this trinomial, you need to factor it so that it can be simplified. Since it's a trinomial, we can do regular ABC factoring on this. So we can divide a 2 out of all three of those numbers. That leaves us with x squared plus 10x plus 25. Factoring that trinomial, we get x plus 5 times x plus 5. So there we have it factored. 2x plus 5s, 1 comes out to the front. It gets absolute value bars. So we get the absolute value of x plus 5, and all that's left in the radical is the 2, square root 2. And again, you can use the bars, or you can do a plus and minus with parentheses. It means the same thing. All right, example 4. Now something crazy happens when you have more than 2 x's coming out. Let's say you have x to the 4th, which means when you factor it, you have, of course, 4 x's multiplied together. So the first 2, 1 comes out, it gets absolute value bars. The second 2, another 1 comes out, it gets absolute value bars. So all we have left now is the absolute value of x, and since there's 2 of them, it is squared. If x is positive, a positive x squared would be positive x squared. If x was negative, a negative times a negative is also a positive. So in this case, you only have x squared as an answer. The bars go away because they multiply out. Okay, so now we're going to do variables with an odd index. Somewhat easier than an even index. So number 3, variables with an odd index. So we're talking cube root, 5th root, 7th root, 9th root, those kinds of things. The nice thing about odd indices, cube root, 5th root, 7th root, is there is no mystery. There is only one answer. That's because when you raise a number like x to the power of 3 and negative x to the power of 3, you actually get 2 different answers. X cubed is xxx, which is a positive x cubed. Negative x cubed is negative x times negative x times negative x, which ends up being a negative x cubed. So only one answer is necessary. Let's do an example. We're going to do the cube root of negative 27x to the 4th. So we start the same way as usual. We're going to prime factor. Now here's where it's a bit different. Whenever you have a negative under an odd index, that negative is going to come out. One way to think about it is, you know that 27 is 3, 3, 3. Each 3 gets its own negative, and then you have 4 x's. So that's one way to think about it. 3 negative 3's, 1 comes out. I have a negative 3 in the front. Out of my 4 x's, I can take 3 of them out. So I have an x out front. Again, no plus minus, just a plain x. And all that's left is the cube root of an x. So when the index is odd, a negative 1 will always come out. That's one way to look at it. Here's another way to look at it. If you have the cube root of, let's say, a negative 5, you can factor the negative 1 off of the 5, and you know that negative 1 times negative 1 times negative 1 is still going to be negative 1. So 3 negative 1's, 1 comes out to the front. And that's why this simplifies to negative cube root of 5. Okay, last topic we're going to cover is Roman numeral 3, multiplying. Multiplying is pretty straightforward. When you multiply 2 radicals, first thing you do is make sure that the roots match. Roots must match. If the roots do not match, you cannot multiply them in radical form. Game over, you're done. All right, so check for that first. Second step is you're going to multiply the radicands together. Step 3, you're going to multiply the scalars together. And step 4 is what we've just been practicing. Once you have the two numbers multiplied into one number, then you're going to simplify that one radical into the form that it needs to go. This is pretty easy, so I'm just going to show you one example and call it good for the notes today. Here is our example. 3 radical 5x times 2 radical 10x. So first thing you do is double check that they have the same root or index. This is a root 2, remember the invisible 2, this is a root 2. So because they are both a root 2, we can go ahead and multiply. All right, following the directions that we just wrote down, you're going to start by multiplying the radicands together, and then you're going to multiply the scalars together. So our scalars are 3 and 2, so 3 times 2 will go to the front. Our radicands are 5x and 10x, and they get multiplied under the same radical. Now we can simplify. 3 times 2 is 6. I could multiply these together, but since I have to prime factor them right back out again, I'm going to skip that. So 5x is 5 times x. 10 is 2 times 5, and it has its own x. So 5 and a 5, 1 comes out. An x and an x, 1 comes out. We have a root 2, so it's absolute value of x. And all that's left is a lonely 2. So 6 times 5 is 30. Absolute value of x. Square root of 2, because that's all that's left. And there's your multiplication. I hope you've enjoyed taking notes. Make sure that you are taking notes and keeping them. We will be turning in notes at the end of the semester to help boost up your grade and give you credit for all your hard work taking notes.